Okay. Now the question is prove that under root 3 is irrational. Okay. You have to prove that it is irrational. See, of course, the rational one is that it is P in P upon Q form, right? But it is irrational. So that means it is not in the form of P upon Q. Yes or no?
Yes, ma'am.
Right? So over here, what is happening? You already know that it is irrational, right? You know this is irrational. But again, the question is they are asking you to prove it. So by the good end, they are not getting it that this is irrational. So what you have to do, you have to make a story and then you have to prove that this is irrational. You can see that this is irrational, right? But here you have to make a story and then you have to tell it. So this is the story. We have to prove that under root 3 is irrational, which you know that it is irrational. So for example, I'm not believing that this is irrational, right? So at that time, you are like, okay, if you think that you are not wrong, so let's assume that under root 3 is rational. Clear?
Yes, ma'am.
Okay, so what you will assume, you will just write it like this. Let us assume the opposite, that is under root 3 is rational. Okay, so if it is rational, that means it can be written in the form of A upon B, or you can say P upon Q. Yes or no?
Yes, ma'am.
And B should not be equals to 0, right? So here under root 3 can be written in the form of A upon B, where A and B are co-prime. Co-prime means that they are the number that will be coming in the table. Okay, A and B are the co-prime and B should not be equals to 0. Co-prime is they don't have any common factor other than 1. They should come in the 1 tables and they should know co-prime, you know, right? Prime means that that for example this 2 comes in 1 table and in 2 tables, that's it. Similarly 3 comes in 1 table and in 3 tables, right? They don't have any other factor other than 1, right? But for example 10 comes in 1 table, in 2's table, in 5 tables. So other than 1 they have other factor as well, right? As well as in 10 tables. So this is not correct. But co-prime are basically the one who will come in their table as well as in one table. That's okay. So over here, you know that under root 3, you are saying that it is irrational, but I am not believing it. So you said me, okay, you are not believing it. So let's just take, you are saying it is rational. So let's just take under root 3 equals to A upon B. Okay. Now this B will come this side. This is in division. Yes. So I hope you know this symbol. For example, someone is in plus. So when it will go to here, it will be
Minus.
in if it is in minus, then it will be in plus. If it is in multiplication, it will be in division. If it is in division, it will be in multiplication. Right? So this B is in division. Right? So when this will go here, right, it will be in multiplication. 3 multiplied by B equals to A. Right? So it will be under root 3B equals to A. Right? Now over here, this is the step. So first step, like you have to learn the lines. First you will write that let us assume that under root 3 is a rational number. And then you will write if it is a rational number, it can be written in the form of A upon B, and A and B are the co-prime number and B should not be equals to 0. Right? So now under root 3 equals to A upon B. Now B will come this side. Now you will square these two. You will square this one as well as this one. So when you will square it, this root and the square will be deducted, right? So here it will be 3b square, right?
Yes, ma'am.
And here it will be a square. Yes?
Yes.
Now, once you got this, now this a, this one, it was 3b square and it was a square. Now this 3 will come this side. So it will be b square equals to a square divided by 3. Yes?
Yes.
So this means this 3 divides A as well as B, right?
Yes, ma'am.
Yes, because A and B, they are equal, right? They are the co-prime number. So if this is dividing A, that means 3 divides A square as well as A. See, if it is dividing A square, that means it also divides A, right? So 3 divides A square and A. Clear? So by theorem, if P is a prime number and P divides A square, then P divides A, where A is a positive number. This is a theorem that if any number is dividing the square one, right? That means it will also divide the A one as well. For example, 25, right? 25 is the square of what? 5?
Yes.
And okay, let's just listen to it very carefully. See, for example, 5 square divided by 5. Okay, so 5 square is what? 25. So this 5 is dividing this 25, right?
Yes.
If you will remove this, again this 5 is dividing this 5, right?
Yes.
So this means that this 5, which is this 3, it divides 5 square, which is A square, as well as if you remove the square as well as A. Right? This is a theorem that if it is dividing any number which is dividing the square, if you will remove the square, it will also divide that as well. Clear?
Yes, ma'am.
Okay. So now this is the thing. So if 3 is dividing A square, by theorem you get to know that 3 is dividing A square. So 3 shall divide A also. Clear?
Yes.
Okay. So this is the first equation from your end. That 3 divides A square as well as A. Clear? So we got this. Now, hence we can say that A upon 3 equals to C. Now, see, right now you must be wondering, oh my God, what is this? Right? But you have to learn the steps. And this is what you have to mug up. There is no chance or there is no anything else. This is a whole story. These are the steps that you have to learn. That, okay, first you will, for example, you will write A equals to B. And then you will just put something here and it will come this side. You will square it. These are the steps. You cannot skip any step. Once you are done till here, then see, this was A upon 3. Now this A upon 3, you are going to take it equals to C. This is the step. There is no logic why you are taking it C. But this is the logic that you have to take it equals to 3. Right? So A upon 3. Now the question is from where it came. It came from here. Right? A upon 3. You just removed square and it was 3. So A upon 3 equals to C. So that means A equals to 3C. Yes, this 3 is in division, so it will come here in multiplication. So now A equals to 3C. Yes or no?
Yes, ma'am.
Okay. Now, after this, now we know that 3B square equals to A square. Yes. You remember this one, this equation?
Yes, ma'am.
3B square, A square 1, this one. This equation, right? This
Yes,
equation. So over here, you know that it is equals to this one, right? 3B square equals to A square, you know that. And here, you are saying that A is equals to 3C. Yes? So what you will do, instead of this A, right, you will write 3B square. Clear? Okay. So instead of A, you wrote 3B square equals to 3C square. Clear? Because it was A square,
Yes, ma'am.
that's why it is 3C square. Clear?
Yes, ma'am.
Okay. Now over here, 3B square and 3C square. So it will be B square will remain here. 3C square divided by 3 because these were in multiplication. So 3 and 3 got cancelled. B square equal, it's 3. Wait a minute. It's 3B square and this 3C whole square, right? So 3B square equals to 3 whole square is 9C square, right?
Yes, ma'am.
And then 9C square divided by 3. So it is B square equals to 3C square, right? This is what. Now this 3 will come here. It will be B square divided by 3 equals to C square, right? So again, the same thing is that 3 is dividing B square. So that means 3 will also divide B, right? If 3 is dividing B square, then 3 will also divide B, right? So hence 3 divides B square. So again the theorem, if P is a prime number and P divides A square, then P divides A. where a is a positive number. So 3 also divides b also. This is the second equation. First equation was that 3 was dividing a square as well as a, right? And second
Yes.
equation is 3 is dividing b as well as b square. Clear?
Yes, ma'am.
Okay. Now, over here, by first and second equation, you get to know that 3 is dividing a as well as b, right?
Yes, ma'am.
So hence, 3 is a common factor of a and b because 3 is dividing a as well as b. It's common,
Yes,
right?
ma'am.
So over here, but you told me that ma'am, they are co-prime. They cannot have any common factor. So how can this 3 is coming as a common factor? So a and b, they have a common factor which is 3. Therefore, a and b are not co-prime, right? Because for prime numbers, they don't have any common factor. But here you are getting 3 as a common factor. So that means this is co-prime. So how come it can come that they are not co-prime? So this conclusion is coming because our assumption was wrong. Right? What you assume? You assume that under root 3 is a rational number. Right?
Yes, ma'am.
That's why the answer here it is coming wrong because you assume the wrong thing. So by contradiction, we can say that under root 3 is a irrational because you were not, see, everyone knows that under root 3 is irrational, but I was not believing that. So you said, okay, you are not believing it. You are saying that it's a rational number. Let's just take a rational number and make a conclusion. If the conclusion will come wrong, that means our assumption was wrong. And here the conclusion is coming wrong. That means whatever we assumed, that was wrong. Right? So if it was not working with a good way, then you moved the entire story and you proved me wrong. Then, ma'am, you were wrong. Right?
Okay, ma'am.
And this come for 4 marks directly. So you have to, instead of 3, they will be giving you 5, under root 5. They will be giving you under root 2. Any number they will be giving you, but you don't have to feel like, here, if it is under root 3, you are taking 3. If it will be under root 2, you will take 2, like that one. Clear?
Okay, ma'am.
So again, we will just go through it again, once again, then you will write it down. Clear? You will learn it because when we will solve the questions from exercise, na? So at that time, I will be giving you a question and you will be solving it. Like you will be looking at the answer, which this we have done, but steps will be same. Only the figures will be changed. Clear? And instead of under root 3 here, there will be under root 5 or under root 2. Clear?
Okay, ma'am.
Okay, so let's just again start. We have to prove that under root 3 is irrational. So you said we have to prove that under root 3 is a irrational number. I was not bothering about it. I was not believing you. So you said that, okay, ma'am, let's just assume that under root 3 is rational number. Clear? So if it is a rational number, then you can represent it in the form of a upon b, right? And at that time, a and b should be co-prime number and b should not be equal to 0. Co-prime number means that they should not have any common factor other than 1. Okay. So I said, okay. So I just wrote under root 3 equals to AB and you just got this B here. Then you did squaring both sides. So you got 3B square equals to A square. Okay, this is what you got. Then over here, now 3B square equals to A square. So now this 3 came here, A square upon 3. So from this you get to know that if this 3 is dividing A square, that means it will also divide the A. Right? If this is a theorem that if any prime number is dividing a square, then it will also divide the a part. Right? So that means I got to know that if this is dividing a square, it will also divide the a. So this is our first equation that, okay, 3 is dividing a. Right? Then over here, now this is for a. Now you have to do something magical. Now you have to bring some other component which is c. So over here, a upon 3 equals to c. You just wrote a upon 3 equals to 3. Right? So over here, a equals to 3c, right? But earlier also you got an equation, right? Which is this, that 3b square equals to a square, right? So now putting a equals to 3c. So in this equation, you will put a equals to 3c. Clear? So here it was 3c. So I just wrote 3c and 3b square like this. And putting the value from here, you got to know that b square equals to 3 square. Now this 3 will come here. Right? So from this also you got to know that 3 is dividing b square. So it will automatically divide b as well. Clear? So this will be your second equation. Clear? So from first and second equation, we got to know that 3 is common factor of A and B, right? So this means that they are not co-prime number. Why? Because in co-prime number, they do not have any common factor, but 3 is common for A as well as for B, right? So why this conclusion is coming wrong? Because your assumption was wrong, because our assumption is wrong. So by contradiction, we said that under root 3 is a irrational number, hence proved. Clear?
Yes, ma'am.
Okay. So now you will just know.
So can you scroll a bit?
Down.
Yes, ma'am.
Okay.
Ma'am, please scroll. Please scroll down. Please scroll. Please scroll. Please scroll down. Yes.
Okay, done, Jasleen?
Yes.
Okay, so now what you are going to do basically, now I'm giving you 5 minutes. You will quickly revise this one, and then I'll give you 5 more minutes without like you will hide the answer, and then you will write this again under root 3, like proving under root 3 irrational number on your own. Clear?
Yes.
And revise it and tell me if any line you are not getting or you are like, ma'am, how to remember that? Just ask me. Okay?
Okay.
Okay, Justin, any doubt or anything?
No.
You're doing it again?
Yes, ma'am.
Okay. Okay. So I hope this concept is clear to you, right? Now coming to C, if it is only the single one, for example, under root 2, under root 3, like that, so that means you just have to follow the all the steps that, assume this, then all the steps. But for example, if it is this, 5 minus under root is irrational, right? So over here, you have to prove that this is irrational. You can find out this under root 3 is irrational so easily. But this one is very simple, right? So let's just do it. So first of all, what you will write, we have to prove that under root 5 minus under root 3 is irrational. So let us assume the opposite, that this is rational, right? Hence, this can be written in the form of this, and A and B are the co-prime and they should not have any other factor other than 1. So you will write 5 minus under root 3 equals to A upon B. Now this under root 3 will remain here and this 5 will come. This is in plus here. This is in plus. So it will be here A upon B minus 5. Clear? Now what you have to do, you have to take the LCM. Okay, I hope you know that this is basically, listen to it very carefully, A upon B minus 5. So this means it is 1. So B and 1 will be B, right? In B tables, B comes at what time? At one time, B 1 ja B, right?
Yes.
Okay, so 1 multiply by whatever is written here, A. Okay, then mine, B, in one table, B will come at what time? You will multiply 1 with what, that you will get B.
B.
So here you will write B multiply by whatever is the numerator, it is 5. So over here it is 1 multiplied by A is A minus 5B divided by B. You got this?
Okay.
Okay. Now, after this, what you have to do, like this one will remain here. Now, this one, this minus you will bring it here. So it will be under root 3 equals to minus will come here. So now it will be 5B minus A divided by B. Clear?
Yes.
Now you can say under root 3 is irrational number, right? But this one is rational number. Yes, because this is in form of A upon B, right?
Yes.
So over here, this is a rational number, but under root 3 is a irrational number. So this is coming. That rational number, see, one is rational and one is irrational, right? So
Yes.
you cannot say they both are equal, right? So this is again, it is coming wrong. Why it is coming wrong? This is a contradiction because our assumption is incorrect, right? So hence under 5 minus under root 3 is also irrational, hence proved. Clear?
Yes.
Okay. Quickly write it down. Wait a minute.
Anything is going down. Ranking is grown. Ranking is grown. Ranking is grown.